Okay, welcome back. Update on the cat situation. He's now prowling back and forth in front of the table with his head down and his tail down like a little devil panther. But so far, no attacks have occurred. So we are ready to take de Moivre's theorem to the next step. So we know how to raise a number to an exponent. How about if we want to take a complex number, like say 8 cis, I don't know, 120 degrees, and we want to do the cube root of it. We want to do the cube root of that number. Well, we know enough already that when you do the cube root of a number, that's the same as raising that number to the 1/3 power. So de Moivre's theorem is going to help us do this. There's going to be one extra little step that we got to throw in that I'll talk to you about here in a minute, but de Moivre's theorem is going to make this pretty easy. So all we got to do is we got to raise 8 to the power, so 8 raised to the 1/3, and then we have to take the angle times the exponent, so 120 times 1/3. Now 8 to the 1/3 means the cube root of 8, and we all know the cube root of 8 is 2. And then 120 times 1/3, that's 40 degrees. So it turns out that 2 cis 40 degrees is actually one of the cube roots of 8 cis 120. Notice I said one of the cube roots. You guys are familiar with the fact that in real number land, all the positive numbers have 2 square roots, right? Not every number doesn't just have 1 square root. You know, if we do the square root of 36, well, the square root of 36 is positive 6 and negative 6. So it's possible for numbers to have more than 1 root. Now, that's not true for cube roots in real number land, but in complex land, numbers do have multiple cube roots, and there's going to be 3 of them. Now, if we were doing square roots here, there would be 2 of them. We're doing cube roots, there's going to be 3 of them. If we were doing the 4th roots, there would be 4 of them. If we were finding the 5th roots, guess what? Shocker. There's 5 5th roots of every complex number. If we were doing 6, you get the point. All right, so there's going to be 3 of them. I'm going to name them Z1, Z2, and Z3. Okay, these are the 3 cube roots of 8 cis 120. Now, all of them are going to have the same radius, so they're all going to start off 2 cis. The only thing that's going to be different is that angle, and I'll show you how you decide what that angle is going to be. What's really going on here is, okay, 2 cis 40 degrees is over here somewhere, right? The angle's only 40. Actually, it would be more like up here somewhere, right? So it'd be 2 units away from the center, and then the angle is 40 degrees, so it's up there somewhere. These other 2 roots are going to be evenly spaced around I'm not going to do this very well, but whatever. They would be evenly spaced around the circle, right? If I made a circle like this, these guys are going to be evenly spaced around the circle. And I know I've got these points in the wrong place, but whatever. Evenly spaced around the circle. Now, if there's 360 degrees in that circle, then it's easy to tell how many degrees are between each point, right? 360 divided by 3. So the angle between them is 120 degrees. So we start at this guy, we rotate around 120 degrees, we get our next cube root. You rotate around 120 degrees again, we get our next cube root. So to find the rest of our cube roots, we're just going to add 120. So 40 plus 120 is 160. 160 plus 120 is 280. And there are our 3 cube roots. Let's do one with radians. Let's do the 4th roots of, let's go 12 cis, I don't know, 2 pi over 3, whatever. 12 cis 2 pi over 3. And we want to do the 4th roots of that. So we're taking 12 cis 2 pi over 3 and raising it to the 1/4 power. That's 4th roots. Okay, de Moivre's theorem says we take 12 and raise it to the fourth power, and then we take our angle and we multiply it by a fourth. Okay, 12 to the 1/4 means the fourth root of 12, and then 2 pi over 3 times a fourth would be pi over 6. Now we need to check and see if we can reduce this radical. Radicals always have to be reduced. So 12 is 2 times 2 times 3. There are no prime factors that occur 4 times, so that radical cannot be reduced. This number is the first fourth root of 12 cis 2 pi over 3. And how many fourth roots are there going to be? You guessed it, there's going to be 4 of them. Z1, Z2, Z3, Z4. I sound like a German counting to 4. Get it? Okay. The first of these fourth roots is going to be the fourth root of 12, cis pi over 6. All these other ones are going to have the same radius or absolute value. Remember, we called it that too, or modulus. The only thing that's going to be different is the angle or the argument. So they're all going to start off fourth root of 12 cis. Okay, there we go. The only thing that's going to change is the angle and what we add to that angle. Okay, so let's say 12 cis 2 pi over 3. 2 pi over 3 would be over here somewhere. And so the other two numbers are going to be, evenly spaced around this circle. Okay, so this is Z1, Z2, Z3, and Z4. So they're evenly spaced around the circle. So all we have to do is think about what angle is between each one. Well, we're in radians now, so there's 2 pi radians in this circle. If we chop that into fourths, that means each of these angles is pi over 2, a fourth of 2 pi. 2 pi divided by 4. So to find this angle, all we have to do is start with pi over 6 and add pi over 2. Okay, so that's 3 pi over 6 plus 1 pi over 6 is 4 pi over 6. That is right. Which is 2 pi over 3. Interesting. So that angle is 2 pi over 3. Yep. Okay, and then to find the next angle, we'll take 2 pi over 3 and add pi over 2. So that would be 7 pi over 6. Okay, so that angle is 7 pi over 6. And then we'll take 7 pi over 6 and add pi over 2. So that would be 10 pi over 6, which reduces to 5 pi over 3. So that angle is 5 pi over 3. So there are 4 fourth roots of 12 cis 2 pi over 3. There's 1, there's 2, there's 3, there's 4. And all we did was add pi over 2 each time to get the next angle. Now, if we were doing fifth roots, there would be 5 of them. And can you think what angle we would add each time to get the next angle? It wouldn't be pi over 2. You wouldn't add pi over 2, because if we were finding fifth roots, you'd divide the circle into fifths. And so you would add 2 pi divided by 5. You'd add 2 pi over 5 every time to get the next angle. If we were finding sixth roots, the circle would be divided into 6 pieces. So you would add 2 pi over 6, which is pi over 3. So you would add pi over 3 to get each angle. That really concludes 6.6. I'm going to do one more video because I think that I didn't cover very well earlier the switching from standard form to trig form, from A plus BI form to R cis theta form. So as you're doing your homework, if you think you're having trouble switching forms, then go watch this last video, and hopefully that video will help with those problems on your homework. If not, then this is goodbye. All right, goodbye.